Wallerian degeneration refers to the process that occurs when an axon is damaged, resulting in axonal degeneration as well as degeneration of myelin. The degeneration that occurs in central nervous system is going to differ than the one that occurs in the peripheral nervous system. So in this image, we have what occurs in the central nervous system, and let's go over what happens in the peripheral nervous system in the right. So let's say that this is the cell body. Let's say that this is the axon, and in green, let's say that these are the myelin sheath. So if there is damage, for example, over here, distal to the damage, we're going to get degeneration of the myelin. So distal to the damage, we're going to have degeneration of the myelin. Once this degeneration of myelin occurs, we have myelin debris floating around now. Schwann cells are going to sense these myelin debris, and they're going to activate macrophages, which are then going to come to that site and then eat up all the debris. And the significance of this is that this ultimately leads to the formation of a bud that is going to allow us to regenerate the axon and regenerate myelin. This process is different in the central nervous system. In the central nervous system, if there is a injury distal to the site of the injury, we also get myelin degeneration. But due to three processes, we're not going to be able to regenerate like we are in the peripheral nervous system. The first reason why we're not going to be able to regenerate the axon and the myelin like we do in the peripheral nervous system is due to the blood-brain barrier. Macrophages are going to have a harder time coming to the brain due to the blood-brain barrier, and so they're not going to be able to engulf all the myelin debris and clear up the site to allow for new axon regeneration. That's the first reason. The second reason is we have apoptosis and inactivation of oligodendrocytes. Oligodendrocytes are going to be the cells that make myelin in the central nervous system, and if we have apoptosis of these cells, then we're not going to be able to regenerate new axons and myelin. The third reason is going to be due to proliferation of astrocytes. Now, proliferation of astrocytes are going to secrete ultimately inactivating factors that are going to not allow for new axonal generation, and they're also going to lead to a glial scar formation that is also going to block axonal growth. So, due to these three reasons, we're not going to get the same regeneration that occurs in the central nervous system compared to the peripheral nervous system.